Hello, this is video L, the video that wasn't meant to be. I ran into sort of a timing problem on this. What I'm going to do is talk about Program 1's algorithm design. Program 1, I'm just going to call it Program 1 design. And the reason this shouldn't have been a video is this discussion we're going to have, it's a strange color to discussion, huh? Would much better have been a Zoom session, except the next Zoom session after you're expected to have seen all the videos and read through the program and fully understood it is not until the day the Program 1 is due. So you see what I mean? We got a timing problem. So don't get spoiled. I'm going to do my half of what I hope the discussion would be, and then for future programs I'm going to try to time it a little better so that we'll have a really rich Zoom session where we talk about what needs to be done for the program. I've printed out, I don't know if you have access to a printer, but I printed out my copy of Major Program 1, Enjoy the Staycation with a Pizza, and all that sort of stuff. And let's just, together, shall we, let's look through this and see how much of the logic we can figure out based on our increasingly rich toolbox of C++ syntax and everything else we have at our disposal. The top half of this page, if you look through that, that is pretty scary. Some huge, long double values and numbers and stuff. Some of them are scary, some of them are not. I would say read through. Just start off by reading through the assignment, that and the examples carefully at least twice. Not only that, do close reading of it. Get multicolor highlighters or multicolor pens and mark this up. See if you can do things like figure out which ones of these should probably be symbolic constants versus which ones of these are actually calculated values that can't be symbolic constants because we won't know what those values are until the program's running. They are just freely mixed together in there, and part of your analysis of the assignment is to figure out which things are a permanent part of the program and thus should probably be symbolic constants, and which things are calculated values based on input we get from the user. All that stuff is part of the discussion of the top page. Your Program 1 should perform this business between the heavy lines at the bottom of the first page. That's actually moving pretty far down the road toward what we want to talk about, what I want to talk about, and you have to listen, unfortunately, I'm sorry about that. What I want to talk about with program design, designing the logic, the algorithmic logic of this. So let me just dive in here. First thing, here's what you don't want to do. You don't want to grab your copy of this or have this open in a window and sit down and start typing in your prog1.cpp. No. Bad student. Don't do that. You want to look at this, think deep thoughts, and figure out where the assignment statements need to be. Is there an if in there? Is there an if else? Is there a while loop? Is there a for loop? All that sort of stuff. Analyze this, do it abstractly first, and if you've done that work thoroughly and completely and thoughtfully, then writing the code, oh my, that's almost a formality. That's an afterthought. Anybody could do that. That's the point where we want to be. We might not be there yet, but let's take a look. Your Program 1 should perform the following sequence of steps in order to calculate the total cost of a pizza order. Now, don't get any grand ideas and think, well, you know what? I think it would be better if I did this in a different order. That would be a better program. If you do that, then it's not going to be consistent with the requirements of the assignment and you won't get full credit. So regardless of whether or not it's a better program, that doesn't matter. These are not friendly suggestions. These are requirements. So things do need to be done in this order. Prompt for and read a number of pizzas in a customer's order. Yes, sir. Prompt, read. I told you this is abstract. This is not C++ code. That's that mindless formality that you can fill out after we've got the logic designed. Prompt and read the number of pizzas. I'm going to call that pizza count. From your thorough in-depth studies of example 2, COUNT, I am sure you will remember that a counter is something that keeps up with how many. Typically, it's involved in some sort of counting operation, 1, 2, 3, 4, 5. A running total, on the other hand, keeps up with how much of something, a bunch of stuff added together. Like, if you wanted to know what your test average was, you would need both of those pieces. You would need the running total that was all of your test grades added together, and you would need to count how many tests there were. Then you could use those two to calculate an average. So far, all we have, based on step one, the lonely little step one at the top, is prompt 4 and read a number of pizzas in the order. So we've done that. 2 looks like a big step, and it is. Actually, 2 is almost all of the program. So most of your program revolves around stuff that happens. I'll even put a gigantic, that might even be too gigantic, but a gigantic square bracket to say, this is the bulk of the program. What's the bulk of the program? For each pizza. Now, let's think about that for just a second. We prompt 4 and read a pizza count, but once we get inside, and this is important to thinking about the program correctly so we can actually get it done, for crying out loud. Once we get inside this gigantic square bracket, we no longer are thinking about all the pizzas and all the orders and all that stuff. We are thinking about exactly one pizza. So, when we've prompted 4 and read pizza count, then we focus on just one pizza. That's what step 2 says. I need to move down my square bracket. You might want to wait and start copying this picture later on, by the way. So I'm going to say prompt read pizza count, and let's say 3. If they type in 3, then they want to order 3 pizzas. So what we'll need to do is loop 3 times. I am not going to write loop 3 times. Don't get all worked up about it. I'm going to write loop pizza count times. Colon. There. That's the lead into this big square bracket that contains all the stuff we need to do for exactly one pizza. So once we get inside the square bracket, I'm not worried about 3 pizzas. I'm not worried about 10 pizzas or anything like that. I'm not even worried about taxes. I'm only worried about what I got to do for one pizza. Here we go. Step 2. For each pizza, prompt 4 and read whether or not this is round. So I'm going to indent. We are inside a loop of some sort. I'll worry about that later. That's a technical detail. We are inside here, and I need to what? Prompt read round. P-R-O-M-P-T. Read. Round. Oh, but what is round? Is that what? I don't know. It could be a strange roundness. Maybe it's a double value. Or, I don't know. Maybe it's a, you know what? That's too early to worry about that. This is all just an abstract outline. These are things that we need to do. We're getting these all plotted out so that we've got them in order and we've got the logic design. Then we'll go back and worry about the actual technical details of how to turn that into C++. Now, there's almost a secret message there. Prompt 4 and read whether or not this is a round pizza. If it isn't round, then it must be rectangular. Things that make you say, Prompt 4 and read round. I'll make that a question. Round? Are you a round pizza? Yes. There are certain things we're going to do if yes, you are a round pizza. Is round. Exclamation point. We're happy with a round pizza. Now, there's where the secret message comes in. If it isn't, then it must be rectangular. Since I know you've read through this assignment now at least twice and annotated everything very carefully, you know you do some things if the pizza is round, you do different things if the pizza is rectangular. So I'm going to put my no down here. I don't know how we're going to do for space here, but we'll just throw it up here and see what happens. If no, it is rectangular. And I'm excited about that too. That doesn't look right at all. I'm going to abbreviate that. Is R-E-C-T, short for rectangular. There. If it's round. If it's round. Now I'm going to indent here even further. I'll go ahead and put my dash. That's not a minus sign, that's a dash. I'm going to go ahead and indent because there are certain things I'm only going to do for a round pizza, and that's what I'm talking about right now. Yes, it's round. What do I need to do for a round pizza? Prompt and read for diameter. Man, we are wearing the user out. Prompt, read. And so I don't misspell it, I'll abbreviate. Diam. Prompt, read a diameter. The measure right across the middle of the pizza. And there's a whole paragraph on the diameter. Prompt 4, read a diameter. If the diameter is less than 6 or more than 20, and a hint there, symbolic constants, print an error message to the screen and reprompt and reread until a valid value is entered. That is a mouthful. Something is giving away a hint here. Prompt 4, read a diameter, and then an if diam is, I'm not going to get vulgar with it, use the actual numbers. Those are going to be symbolic constants. If diam is, I'm going to say, if diam is out of range, colon, which means if it's less than 6 or more than 20, I don't even remember the number, so I got to look it up. Good thing I use symbolic constants at the top of my program. If the diameter is out of range, then what am I going to do? Print an error message and reprompt, reread. Print error message. Yikes, I'm going to run into space problems, I can tell already. Print error. Reprompt, reread. Diam. Then print an error message to the screen, reprompt, reread until a valid value is entered. That was only step 2BI. We need to do step 2BII. Calculate the pre-tax price of this round pizza. And I didn't leave any room for that, so I'm going to need to move this down at least one notch. I'm just copying the no. No is rectangular. Grab some space. There. Now, if diameter is out of range, so I indented the stuff I need to do if the diameter is out of range, and I said, no, bad, try it again, and they type in something I can use, maybe 10. That's a nice round number for a pizza diameter. So they do that, now I'll unindent, because I want to calculate the price of this pizza regardless of whether or not the diameter was out of range. All this stuff is stuff I'm doing for a round pizza. First thing I need to do for a round pizza is read the diameter. Second thing I need to do is check and make sure it's valid. Third thing I need to do is to use diam to calculate, CALC for short, calculate pizza price. I'll just call it price. Price. That should be, I hope, all of 2B, if it's a round pizza. Let me catch up. For each pizza, so we're inside this loop that we're going to loop once for each pizza. Prompt for and read whether or not it's round. Done. Prompt read round. If it's not round, it's got to be rectangular. No triangle pizzas allowed. Prompt for and read whether or not it's round. Check. If it's round, then yes. Prompt for and read a diameter. Done. If the diameter is out of range, yell at them and make them type it again. Then we calculate the pre-tax price. Done. And I move this down too far. I'm going to move it back up. This no is just getting moved all over the place. Try to save enough space for all the stuff we got to do. So we'll say that we're done with 2B. 2C. No, it's not round. It's got to be rectangular. Prompt for and read a length and a width. Now, in the interest of space, I'm going to put both of those together, and then I'll issue a disclaimer. Prompt, read, length and width. And as I was writing that, I started my regretting already. This is two separate prompts and reads. Prompt and read the length. Once you've got a length, prompt and read the width. Then you've got a width. I think that's the order that's given, right? Prompt for and read a length and width, yes. So we're going to ask for the length individually first, read that in, and then ask for the width. And now I'm repeating myself already. This one, we're not going to do any validity checking or anything. We'll assume they're smart enough they can type in the length and the width of a rectangular pizza without having to be corrected. So calculate the pre-tax price of this rectangular pizza. Now the reason that I have to do this inside the no part and separately inside the yes part is because I'm calculating price using different values. Here I use a diameter that only makes sense for a round pizza to calculate the price. Down here I will use length and width to calculate price. I'm underlining things that maybe not the actual word that I typed in, that I wrote on the board, but those things are probably going to need to be represented either by variables or symbolic constants in your program. So everything that I've outlined here, yeah, I believe so. Everything I've outlined here is probably going to be a variable in your program. No, I calculated the pre-tax price of the pizza. Then D. print the pre-tax price of the pizza clearly labeled. Now, regardless of how I calculated it, I could have calculated it using a diameter, I could have calculated it using length and width, and in either case, I'm going to end up with a pre-tax price of a pizza. So that does not depend on whether it's round or not. Do you see what I'm saying here? Only things that depend on the pizza being round need to go right here in the indented yes part. Only things that depend on the pizza being rectangular need to be indented down here as part of the no part. Now I unindent. I'm not inside the yes or no either one because I need to that too. I need to print the price of the pizza, Peter Piper Pickle Peppers. I need to print the price of the pizza regardless of whether the pizza is round or rectangular. And here we go. Print price. Man, that was a big lead up for a tiny little statement, wasn't it? Clearly labeled. Well, that goes without saying, so I didn't say it. Print price clearly labeled. You can look at the example output to see what I mean by clearly labeled. Nothing elaborate, just you do need to know what you're seeing on the screen. And you know what? I think that is all of 2. All of 2 represents the big loop. And let me go back and browbeat you about this again. Everything inside this great big square bracket here has to do with exactly one pizza. When we get further down the road, much more complicated programs, this is kind of our first taste of divide and conquer. We concentrate just on what we know about what's going on at this moment. At this moment, I know I've got a live one. I've got a pizza that they want to order, and I concentrate just on that. Are you round on square? Then I divide it even further. Now, inside this square bracket, this smaller one that's nested inside, I only think about, well, what do I need to do for a round pizza? You see how that simplifies my algorithmic development for the different sections of the program? At each stage, I kind of peel away the layers of the onion so I can focus just on what I know about what's going on at this particular line in the program. There's even more indentation. I've decided to use a convention of square brackets to group statements together. What's going on here? Why is this indented even further? Well, if I get this far in the program, then I know they typed in a diameter that was bogus. You can't use that diameter. I can't make you a pizza of -9 inches in diameter. So if we get one that's out of range, then we do this stuff. If we get this far into the program, then we know an awful lot about what's going on. We know not only that they are ordering a pizza and it's round, we also know that the diameter they typed in was wrong. So these statements have to do with nothing but that one particular very focused case. What do we do in case of a bad diameter for a round pizza? What about these? Well, we only do those for a rectangular pizza. That's why those are grouped together. Why is print price not inside either one? Print price is something we need to do for a pizza. Just a pizza, whether it's round or rectangular or either one. I'm trying to explain why some of these things are indented and bracketed together and why some of them are not. That all followed almost verbatim directly from steps 1 up here. Step 1 didn't have much to it. Step 2. Step 3. This is a loop, by the way, that we're going through pizza count times. This is one and done. We do this one time. Once. Loop, possibly several times. I guess if they type in zero pizzas, I don't want any pizzas. I just want to mess with your online program to order pizzas. Then it's not going to do any of that. We don't need to blend that into this discussion. What happened? What do we know? What do we know about where we are in the program after we fall out of this loop? What we know is we've gone through and calculated all of the pizza prices for all of the pizzas that they want, regardless of whether they're round or rectangular. We don't even care anymore. Been there, done that. If we get finished with this loop, we know that we've gone through and calculated prices of all the pizzas. Then we're ready to do one more once thing down here. We do the summary. After all info for all pizzas has been entered, we've gone through step 2 as many times as we need to. We got to do some stuff. I'll indent. Print the count of the pizzas and the subtotal. Print pizza count. It took us that long to print out how many pizzas the user decided that they wanted to order. Print pizza count. I gotta spell it. pizza count. And subtotal price of all the pizzas. And pizza price subtotal. Not PR. I'm sorry. Pizza price. I didn't use pizza with price. I'm just going to call it price subtotal. That's what happens when you try to design code in real time. You do get to go back and change it. That's a good thing. Price total. Price subtotal. I cannot multitask. We have a little bit of a problem. This is the first time we've even seen that variable. Price subtotal. That's nowhere up here. I just made that up as I was writing out that statement right there. You know what? I'm going to procrastinate. I'm going to come back and worry about that later. Calculate and print the sales tax on the entire order. The entire order is the calc and print tax. I'll make that short and sweet so I can spell it. Tax on pizza price subtotal. There. Still ignoring the price subtotal elephant in the room. Calculate and print the 6%. You know, that could change. They might decide, you know what, for us to be able to be financially solvent in Kentucky with all that's going on, maybe it needs to be a 16% sales tax. So we'll make that a symbolic constant at the top so that we can modify our program later for different constraints. We're thinking ahead. Calculate and print the 6% sales tax on the entire order. Done. Print the grand total for the pizza order. But print, not price subtotal anymore. This will be price total. Yet another new variable that until this point showed up nowhere. Here's our conundrum. Here's our problem. Not that we're only doing this once. I'm doing this to keep my labeling consistent. The problem is I don't have a price subtotal. All I did was go through one pizza at a time, calculating one price each time. One and done. I calculate it, I print it, I forget it, I go to the next one. I'm all of a sudden realizing that I didn't leave enough space on the board. Print price. I intentionally use this name, subtotal. This is a running total. In your extensive review and study of example 2, you do remember what running totals are. You do remember what counters are, right? In case you've forgotten, allow me to refresh your memory. Counter, almost always, here's how it works. One and only one time, you set it to 0 at the top of your program. Almost every time, you go through a loop, add 1 each time. Okay, I've been through once, I've been through twice, I've been through 3 times, and so forth. When you're finished with the loop, ta-da, you've got a count of how many times you went through the loop, or how many times you did whatever it is you were trying to count. That's a counter. That's not what we've got here. This is a total, subtotal. Subtotal, you also set that to 0, called the initialization statement. Set that to 0 at the top of your program. Then instead of adding 1 each time we go through the loop, see, here's where I really miss having the class here. We're supposed to be discussing this, not me just preaching it at you. Okay, class, I'll ask you. I set price subtotal to 0 up here. I'll let you think while I do that. Before I even start prompting and reading, I'm going to set price subtotal to 0, also known as initializing it. I'm going to make it look like money, because it is money. 0.00. That is the same as 0 as a double value. And yeah, I do want to make it a double value because it might not come out even. It might have some loose change to go along with the dollars. So I'm going to set price total to 0.00. And the next time we see it is printing it out down here. Here's how running total works. You set it to 0. You go through a loop. You don't add 1 each time. You add some other quantity. Some other quantity that you want to add up. I want to add up all my test grades. I want to add up all the eggs that were in my Easter baskets, whatever it may be. What do I want to add up here? I want to add up all the pizza prices to get a total, to get a subtotal of all the pizza prices. It's only a subtotal because I haven't taxed it yet. But I got to add up all the pizza prices that I calculate as I go through here. And then, by the time I fall out of the loop, price subtotal is ready to roll. I can't do it. I can't start thinking about it like I did after the loop. I have to think about it in the loop because that's the only time I got that pizza price. Anything I want to do with the price of this pizza, pizza number 2, anything I want to do with that pizza price, I better do that right now because that variable is about to get reused the next time I go through my loop. So I didn't leave space, and I apologize for that. Print price, semicolon. I'm going to put 2 statements on one line. Bad C++ programming. But print price, I also need to add price to price subtotal. Let me get down here so I can write it legibly, and then I'm back out of the way. I'm writing price subtotal. Ladies and gentlemen, that is a classic use of a running total. You initialize it to 0. You go through a loop. Every time you go through the loop, you add something to it. We're adding price to price subtotal. Over and over and over again. Don't print it out. We don't need it yet. We don't need it until we've read all the pizzas. All 16 of them, all 2 of them, whatever it may be. But when we're finished with the loop, if we've done this every time, add the price to the price subtotal, then by the time we fall out of the loop, this is already set. There's no more calculation to do. We'll already have the price subtotal. By the time we finish the loop, we can print that out. We can print out the pizza count. We had that on day 1 way up here. We asked the user to type in how many pizzas they wanted. Then we calculate and print tax on price subtotal. That's just a calculation, like calculating the temperature, calculating the area of a pizza. That's also going to be a formula. So we calculate the tax based on the price subtotal. How do we print the price total? There's another variable out of nowhere. Well, the price total is just these 2 added together, the subtotal plus the tax. So that's fairly straightforward. What may not be straightforward, I've got to keep an eye on the time. What? Oh, I thought it said 2 hours. It said 27 minutes. I'm going to use red and go back and do the stuff that we know how to do. Add tax. Now I'm insulting your intelligence, I know. But this is program 1, so we'll give this one, turn this one every which way but loose, and then you can do this on your own on the future programs. Add tax to price subtotal. And you can use your own variable names. Not only can you, I recommend it. Calculate and print tax on subtotal. That goes without saying. That's the formula. This, set price subtotal to 0. That is ye classic running total. And again, if you don't know what I'm talking about, go back and look at example 2. Prompt read pizza count, loop pizza count times. Now, loop, that needs to be nailed down just a little bit more. We have options. We have a variety of things we could do. We can do a while loop. We could do a for loop. I could just stand here and wave my hand all day. When do we use one? When do we use the other? Well, think about how smart we are now. I think we've discussed this before, haven't we? Generally, we use a while loop when we do not know in advance how many times we're going to have to loop. We use a for loop, generally speaking, when we do know in advance. And by advance, I don't mean when we're typing in the source code for the program. I mean as the program's executed, by the time it gets to the loop, if there's any way we can already know how many times that loop is going to need to execute, then we can use a for loop. It's not known as you're at edit time when you're typing it in. So that becomes the question here, this loop pizza count times. Do we know in advance how many times we're going to need to do this gigantic square bracket that eats up most of the program? The answer is yes. We need to loop that many times. Pizza count times. It's built in, not built in, but it's a variable. It's available. I meant that instead of built in. This could be a while loop. A disclaimer, if you're just so much more comfortable with a while loop, it's program one, you say, you know what, I'm going to use a while loop anyway, knock yourself out. But I'll suggest that a for loop is more appropriate here. For reasons just stated. We do know, by the time we get to this big loop, we do know how many times that loop is going to need to iterate, how many times this needs to go over and over. If they type in 5, they want 5 pizzas, this stuff has got to be executed 5 times. Keep going. Prompt and read, is it round? That's a C out, C in pair, 1-2 punch. We do that all over the place. How about yes and no? Either it's round or it's rectangle. No other possibilities. And we do things if it's round. We do different things if it's rectangular. You're itching to yell it at me. Go ahead, yell it. I'll listen. If else. Exactly right. If else. Now, it says in the assignment, I did this on purpose, that if it's not round, you may assume it's rectangle. You don't have to worry about triangles or trapezoids or any stuff like that. I intentionally limited it to 2 possibilities so that an if-else would be the appropriate C++ syntactical choice to implement this. Here's the true part. Yes, it's round. Here's the false part. Do not test again. There is no additional condition to see if it's rectangular. This is purely the else part down here. It's first good. If diameter is out of range, well, that's built in, isn't it? If diameter is out of range, print an error message, reprompt, read diameter. So let's visualize this together, shall we? I get this far and they type in 100. What idiots. Good grief. Who gets to order pizza these days? They type in 100. Of course, we spew an error message at them, make them type it again, and they type in 200. The way this is constructed right now, it only goes through this one time. If I use an if, there ain't, this is not an English class, there ain't no such thing as an if loop. In other words, we can't force them to stay here and keep trying until they get it right, for crying out loud, which is what we really want to do. So even though I used the word if, that was deceptive, whether or not it was intentional. It should say, while, or as long as the diameter is out of range, print an error message and keep going. Make them do it over and over and over and over again. How does it stop? It stops when they type in a diameter value that is in range. So this is not an if statement at all. This is a while loop. Now, I don't have room to write everything on the board. Not only is it a while loop, but out of range, you test that using a compound condition. Go back and watch the video on conditions. There was a whole video. I think it's the longest video in this series. Go back and look at the video on conditions, and you see all kinds of stuff about compound conditions. The reason that video got to be so long is because those are kind of complicated. And they are logically a little more tedious to unwind and get correct. So rather than going into that and making this the longest video so far, I refer you back to the video on conditions to look at compound conditions to get something that's in a particular range. Okay, this stuff is inside a while loop. Why is it while instead of for? We always have to ask if it's going to be a loop, because we don't know how long the user is going to persist in their stupidity and keep typing invalid diameter values. If they type in something that's valid the first time, if it is in range, it won't ever do that. It won't print the error message. It won't reprompt. We fall out of the while loop as soon as they behave themselves and type in a valid diameter value. This is the else part to go with it. You know what? I'll put the if up here. If ... leading suspiciously, and the matching else ... else is down here. There. I like that better. This is more an art than a science, as I'm sure you can figure out. This is designing the code, and I'll refresh your memory with a comment I made at the beginning of this video, or my memory, I think I said so. If you do this very carefully and very completely and very precisely, then it really does almost become a formality of translating your pseudocode, that's what this is called, pseudocode, is fake code, into actual code, into C++ code. So if we've done this thoroughly and carefully, then it's a matter of throwing this in your editor as C++ code and letting it roll. What have we got here? Read, prompt and read length and width, do that separately. Use those to calculate, that's another formula. I should be writing formula or something over there. That calculation is just a straightforward, okay, I'll give it away. Length times width, there you go. Use that. Print the price before it goes away because we calculate a new one. We did calculate them, right? Yeah, calculate there, calculate there. So we do have a price by the time we get to print price. And this should have been a separate statement down here beneath it. Add the price to the price subtotal. That's part of using our running total. When all that's done, after the for loop completely executes, it exhausts itself. After we've exhausted the for loop, after the system's exhausted the for loop, and yes, that's the word that's actually used. Then we're ready to print out pizza count. We had that from the beginning. Price subtotal, we calculated that as a running total as we were going along. Calculate and print the tax on that's a calculation formula. We're almost there. Dragging ourselves toward the finish line. Print the price total. That's a calculation. You get the total by adding the tax to the subtotal. What could be simpler? Well, gobs and gobs of things, as you know by now. But, again, that's the sort of analysis I want us to do on future programs in our Zoom sessions. And I will try to, don't know that I can promise it, but I will try to time it so that we're synchronized and ready to do this when we are ready to have one of our required Zoom meetings. But I apologize for insulting your intelligence and doing all this stuff when you had all this stuff figured out anyway, didn't you? Get together with your coding buddy and discuss the finer points and the ins and outs and all that sort of stuff. And we can discuss it office hours, Zoom class, or whatever. I'm moving toward the computer because I'm going to say see you online. Bye.